Hello everyone, welcome to the video lecture series on microprocessor and peripheral interface. In this video lecture, we are going to cover 8254 control word register and the operating modes. So, first point is 8254 control word register format. Total 8-bit control word register is available in 8254 and the format is represented here. 6th and 7th bit are select counter bits, that are SC0 and SC1. These bits are used for counter selection. Then 4th and 5th bit, it is RW2 and RW1. These are read and write operation, or we can also call it as read or load bits. Then 1, 2 and 3, it is M0, M1 and M2. These are used for deciding the programming modes. And the last bit, it is BCD or binary. This last bit or LSB of the control word is used for selection of counting, whether that counting is BCD counting or binary counting. If this bit is 0, then the counter will act as binary counter, and if this bit is 1, then counter will count the BCD counter. Now we'll see the use of each field in this control word register format. So as we have seen, 6th and 7th bit, these are used for selection of counter. So if these two bits are 0, then our counter 0 is selected. If the bit SC0 is 1 and SC1 is 0, at that time counter 1 is selected. If it is 0 and 1, counter 2 is selected, and for 1 1, it is read back status. That means 8254 read back command is selected if both the bits are equal to 1. After that, this RW, here it should be RW0 and RW1, or you can also consider it as a RW2 and RW1. So if it is RW2 and RW1, if both bits are 0, then the counter latching operation or counter latch command is selected. If it is 0 1, then read or write the lower byte, that is read or load the LSB is selected. If it is 1 0, read write the upper byte or MSB is selected. And if both bits are 1 1, in that case read or write lower byte followed by upper byte, means first LSB is read or write and then MSB will be read and write. So these are the read or write selection bits, bit number 4 and bit number 5. In some books it is represented as RL0 and it is RL1. Next is mode selection bits, that is first, second and third bits, M0, M1 and M2. If these three bits are 0, mode 0 is selected. If it is 0 0 1, mode 1 is selected. If it is don't care 1 0, mode 2 will be selected. Don't care 1 1, mode 3 will be selected. And if it is 1 0 0, mode 4 will be selected. And for 1 0 1 status of these bits, mode 5 gets selected. So by this way, by selecting the counter, we can use these two bits. For read or write operation, these two bits are used, and for operating mode selection, these two bits are these three bits are used, and for counter, whether it is BCD or binary, for that this last bit or LSB bit is useful. So by this way, this is the controlled word register format, and by putting the appropriate values in each field, we can select the required counter operation. Now we'll see the operating modes of 8255. So total 6 modes are present in 8255. Mode 0, it is called as interrupt on terminal count. Mode 1, it is programmable one shot. Mode 2 is called as rate generator. Mode 3 is square wave generator. Mode 4 is software triggered mode, and mode 5 is hardware triggered mode. Now we'll see each mode in detail. So mode 0, it is interrupt on terminal count. So this mode 0 is used to generate an interrupt to the microprocessor after a certain interval. Initially the output is low after the mode is selected, means once the mode is selected as mode 0, output is low, and output remains low after count value loaded into the counter. The process of decrementing the counter continues till the terminal count is reached. That means the count becomes 0 and the output goes high and will remain high until it reloads a new count. The gate signal is high for normal counting, and when the gate goes low, counting is terminated and the current count is latched till the gate goes high again. So these are the details about mode 0. Now we'll see the control word format for mode 0. So in this mode 0, we are selecting mode as 0, then counter we are selecting as 0, read or load LSB data byte only, and BCD counter. These are the details for this, and according with that we are going to put the values here. So these two bits are for counter selection, so counter 0, that means these two bits are 0, then it is 0 and 1, that means read or write LSB only. So here read or load LSB data byte, that's why here it is 0 1, and these 3 bits are for mode selection. For mode 0, these 3 bits are 0, and this last bit is for binary counter or BCD counter. So it is 1, that means this counter is our BCD counter. So according with that, for this control word register we have put the values, and we have calculated the value of control word register as 11H. So for mode 0 with counter 0, read load LSB data byte first and BCD counter, our control word register value will be 11H. Now we'll see the details by using this timing diagram for mode 0. There are 3 different cases for mode 0. First we'll see the simple case, or it is also called as a normal operation. So here what happens, first of all the counter should be initialized and then the loading operation is performed, and for that purpose, for initialization counter one write is required, and for loading the operation the another write operation is required. That means in each mode of 8254 total 2 writes are required. One write for loading the counter or for counter initialization, and another write operation is for loading the operation. So 2 writes are present, that's why here we can observe in this write bar signal there are 2 times the write will be activated. When this signal is active low, we can call that our write is activated. So here first of all the control word register for counter 0 is loaded or written. So that control word register value we have just calculated, which is 11H, and after that to load the count value another write is required. So here the count value is given as 5H. So this is the count value. So counter is initialized by this control word register, and then loading operation is performed by providing this count value. Then when the counter is initialized in this mode 0, the output goes low. Here we can observe, here in this case or at this location our counter is initialized. So once the counter is initialized, at the negative going pulse of this clock cycle, our output goes low. Okay, after this what happens, the data of counter, that means 5H, is loaded and it is transferred to the counter on next going edge, low going edge. So here it is loaded, counter gets loaded with value 5, then at the next negative going pulse of this clock cycle, our counter is loaded with this 05H, and now our counter will start counting, means now our counter will decrement from given value till 0. So for each clock cycle, this is one clock cycle, for one clock cycle counter gets decremented by 1. For another clock cycle again counter gets decremented by 1. Like this our counter value becomes 0, and once our counter value becomes 0, our output will go high. So by this way, here the counting is performed in normal operation, and in this normal operation here we have assumed our gate signal, it is always high. Then second case, in this second case the operation is similar like operation 1, only the difference is in this gate signal. In this first case we have observed that gate is always high, means activated, but here in this second case the gate is disabled one time. So when this gate gets disabled, our counter will suspend the counting. That means our counter is starting counting the value. Here counter is loaded by value 3 at the negative going pulse of the clock cycle. So counter started counting, decrementing this value, so 3, 2, and here what happens, the gate is disabled. So once the gate is disabled, counter is suspended, means counter value will be stopped counting, so it is showing the value 2. And once our gate becomes high, then our counter will again doing the counting work from previous value. That means from 2 again counter is decremented to 1, and again from 1 to 0, and once counter reaches 0, output is made high. This is the second case. In third case what we can observe, that first our counter is initialized by giving this control word register. The count value is given, and after again few clock cycles again the next counter value is provided. So in this case what happens, gate is considered as always high, enable. So once this 4 value is provided to counter started counting, that means 4, 3, 2, and after this clock cycle what happens, the new value for the counter is provided. So once counter gets this new value, counter will count the value from this new value. It will suspend the previous counted value, or previous count value will be suspended, and the new count value will be considered, means counter gets initialized by this new count value and it will start counting from this new count value, means 3, 2, 1, 0, and it will go high. So this is the mode 0 for 8254. After that, second mode is mode 1, which is programmable one shot, or it is also called as hardware trigger one shot. So it can be used as a monostable multivibrator. The gate input is used as a trigger input in this mode. The output remains high until the count is loaded and a trigger is applied. The output is normally high after initialization. Whenever the count becomes 0, another low pulse is generated at the output and the counter will be reloaded. For mode 1, the control word register format is represented here. Again here counter 0 is selected, then read load LSB data byte and BCD counter is selected, and according with that, by putting all the values for mode 1, now these three fields will become 0 0 1. Okay, and the control word register value will be equals to 13H. So for this mode 1 CWR is 13H. Now we'll see the details of this mode 1 by using the timing diagram. This is the clock pulse for counter 0. Counter 0 is selected in this case. Now as we know, two writes are required, one for counter initialization and another for count value loading operation. So two writes are represented here. Counter is initialized by control word register 13H, and then count value is loaded in the counter. And in this case, gate is, we can observe, gate is initially at low value, and once the gate is triggered, in that case our counter will start counting. Initially our output is active low, but once the counter is initialized, then what happens, our output goes high. Okay, and the output remains high until the trigger is provided by using this gate signal. So the gate signal is acting as a trigger. Once the gate signal is activated for the clock cycle period, in that case our counter will start counting and the count value will be loaded in the counter. So once the count value is transferred into the counter will start counting, and in that case our output will go low. So here the output goes low and counter will decrement from count value 3 to 1 0, and once the count value becomes 0, again our output will become high. And again if the gate trigger is applied, then again our counter will restart counting by using the same value, that is 3 2 1 0, and so on. So this is called as a normal operation of mode 1. Now in second case, the operation is same, but what happens here, you can observe the gate triggered is provided and our counter has started counting 3 2 1 and so on, but before the counter reaches 0, the second trigger is applied. So once the second trigger is applied, the counter will get reinitialized and counter will start counting again from 3 2 1 0, and once counter reaches 0, the output is activated to high state. So this is second case. In third case, we can observe that count value is provided 4, and before counter counts this 4, the another count value 3 is provided. So what happens here, once the gate is triggered, then the counter starts counting 4 3 2 1 0, and before this counter becomes 0, the next value of counter is loaded, that is 3. But here since it is triggered mode, what happens, the counter will not consider this 3 value unless and until the new triggered or the gate will be give the trigger to the counter. Okay, so here counter is initialized by 4, counter will start counting 4 3 2 1 0, and now after 0 output is high, and counter will wait until the trigger is provided, and once the counter gets triggered, this new count value is initialized in the counter, and now counter will start counting for that new value, that is 3 2 1 0, and so on. So this is mode 1 operation of 8254. Next is mode 2, that is rate generator or pulse generator. The control word register format for counter 0, read load LSB data and BCD counter. That control word register format is 15H. And these are the timing diagrams for mode 2. As usual, the two write operations are required, one for initialization of counter and another for the loading operation. Here the gate is considered as active high all the time, and our output is initially low, but once the counter is initialized our output becomes high. And here the first operation is the normal operation. So once the data is loaded, it is transferred to the counter and counter starts counting, and each time the counter gets decremented by 1 for each clock cycle. For every clock cycle counter decrements by 1. So here counter is initialized by value 4. For our next clock cycle counter will count as 3. Next clock cycle counter will count to 2, 1 and 1 and when the counter reaches to value 1, it makes the output low. Here the output will be made as low. The output remains low for 1 clock pulse. So here our counter value is 1. From this, here we can observe from this point to this point our 1 clock cycle is there, and for this 1 clock cycle period our counter output remains low, means counter will become low for 1 clock pulse when counter reaches to 1. And when the counter becomes 0, the output is made high. Here the counter is 0, so output is made high. The count value is reloaded in the counter, means this 4 value again it is reloaded in the counter, and counter will continue counting in the similar manner. When counter reaches 1, again output will be made low for 1 clock cycle period, and once counter reaches 0, again the counting will be restarted. So this is the red generator or pulse generator. In second case, gate is deactivated in between the counting value. So what happens here? In this case, when the gate goes low, the counter stops counting. Here our counter is initialized and counter has started counting 4, 3, and after this the gate is made low, and that's why counter has stopped counting. Counter is now at 3 again, and once the gate becomes high, then again counter will restart the counting. So 4, 3, 2, 1. Once it reaches to 1, again counter output will be made low for 1 clock cycle period, and once counter reaches to 0, again it will made high and the counting will be restarted like this. Okay, so this is the gate disabled operation for mode 2. And second one, the third diagram, that is case 3, mode 2 case 3, it is the new value. Here the new value is entered before the first counting has completed. So first counter value is 4, it has started 4, 3, 2, 1, again at 1 the counter is made low up to 0, and again from 0. Now what happens now, when counter reaches 0, the output is made high and counter will start counting. But in this case, since the new value is loaded in a counter, counter will start counting for that new value. So counter starts counting for new value, that is 3, 2, 1, 0, again 3, 2, 1, 0, again 3, 2, 1, 0, and so on. So this is mode 2 operation of 8254. Next is mode 3, that is square wave generator. This mode is similar to mode 2, except the output remains low for half of the timer period and high for half of the timer period. This is so because we want the square wave. Control word format for mode 3: counter 0, read load LSB data byte and BCD counter. that control word register value we are getting equals to 17H. So again here we are having different cases. So first, two writes are required, one for initialization of counter, another is for loading operation. So when the counter is initialized in this mode 3, the output is made high. Here we can observe counter is loaded by 17H, then output is made high. When the data is loaded in a counter, now that data value is 4, the counter starts counting. The mode 3 is square wave generator, that's why for half value of this 4, the counter output will remain high, and for half value counter output will remain low. So by this way, for 420 the output is high, and again for 420 the output is low, and so on. So this is, by this way we'll get the square wave generated. So this is the simple operation or simple case in case of mode 3. In second case, and one more thing, in first case the gate is always at high level. In this second case we can observe gate is always at higher level, but the count value provided, it is odd number, that is LSB is 5. Here LSB is 4, that's why half time period is okay for generation of square wave. But for odd value, what happens, counter starts counting from 5 to 4, and now the 4 is even number, so again it will start decremented 420, again 520, again it will start 5420, 520, and so on. So this is the case for odd value of the count. Next is the case in which gate is disabled in between. So once the gate is disabled in between, we can observe counter, what happens with the counter, counter has started counting 420, 420 means counter has decremented by 2 every time for high value and low value, and here again counter is the output of counter is high, and we have observed here the gate is disabled. So when the gate is disabled, the counter gets starting from the first value, that means 4. So 420 means counter value will be initialized once again, and the counter will start counting from 420 and so on. And the last case is the new value of the count. So once the new value is provided for the counter, here the first count value is 5, so first counter gets decremented by 1, again counter decrements after 1, the count will get the even value, that's why again the counter will start decrementing by 2, so 20, again 5, 2, and so on. But before that, here the new count value is provided, so that new count value is considered, and then the counter will start decrementing from that new count value. So these are the timing diagram or timing waveforms for square wave generator, that is mode 3 of 8254. Next is software triggered mode, that is mode 4. In this mode, the output will remain high until the timer has counted to 0, at which point the output will pulse low and then go high again. The count is latched when the gate signal goes low. On the terminal count, the output goes low for one clock cycle, then goes high. This low pulse can be used as a strobe. The control word register format for mode 4, here the control word value we are getting as a 19H. Now the timing waveforms for mode 4. First is normal operation. As usual, 2 writes are required. So once the count value is loaded in a counter, counter starts decrementing the count value by 1. So 5, 4, 3, 2, 1, 0. And once the counter value reaches to 0, the output is made low for 1 clock cycle. So this is normal operation. In second case, gate is disabled. That means in between the counter processing, the gate is disabled. So here counter value is loaded by 4. So counter started counting 4, 3. Again at this location the gate is disabled. So what happens? The work of this counter is suspended. Means counter suspends its operation, stops counting. Okay. And once the gate signal is made high, enabled, in that case counter will rejoin the counting. Means when the gate is enabled, in that case only the counter again it will do its work from the suspended value. So that 3, 2, 1, 0, and once it is 0, the output is made low for at least 1 clock cycle period. In third case, before counter counts the first value, the new count value is provided. So once the counter gets the new count value, the counter will start counting for that new value. Here 4 value is provided. So 4, 3, 2, 1, and before the counter becomes 0, the new value is provided to the counter, and counter will start counting for that new value. Means 5, 4, 3, 2, 1 and 0. So this is mode 4. Mode 5, it is hardware triggered mode. This mode generates a strobe in response to an externally generated signal. This mode is similar to mode 4 except that the counting is initiated by a signal at the gate input, which means it is hardware triggered instead of software triggered. After it is initialized, the output goes high. When the terminal count is reached, the output goes low for 1 clock cycle. Control word value for mode 5 is 1BH. As usual, 1 write for initialization of counter and 1 write for the operation of loading operation of counter. So here what happens? The gate is providing the trigger, and once the trigger is provided, the counter will start counting. So 4, 3, 2, 1, and once the counter reaches 0, the output is made low for 1 clock cycle period. Again the trigger is provided, counter will start counting, and so on. This is the normal operation. In second operation, before counter reaches 0, the second trigger is provided. So once the second trigger is provided, counter will restart the counting value. That means here 4, 3, 2, here again the trigger is provided, so counter will stop counting and counter will be initialized from the initial value of 4, and it will start counting 4, 3, 2, 1, 0. Third case, it is for new value, count value. So before counter starts counting for this new value, for the first value of 03H, new value 04H is provided. But since based on the gate trigger the counter works, here first trigger is provided, then counter starts counting for the first value, that is 03H. So it will count 3, 2, 1, 0, and the output is made low, and again it is high. And once the second trigger is provided on the gate, then and then only the second value will be started counting by the counter. So here the second trigger is provided, so counter will start counting for the new value of 4. So here it is 4, 3, 2, 1 and 0. So by this way the mode 5 operation is there in case of 8254. So here in this video lecture we have seen the control word register format for 8254 and the different modes of operation of 8254. Thank you for watching the video.